In this video, I decided to maybe show you some textbooks that I used to study for real analysis in the PhD program. So I've collected them all and put them over here. You can see that I've amassed quite a collection for a second-year PhD student. Although some of these I've had before, I've collected them over time, and it may not be the largest collection of books out there. In fact, I know it's not. It's probably on the lighter side. But I bet I have more books here than my peers. Not that it's a competition or anything. It's just these are the books that I've read, or at least read some of, in order to prepare for analysis. So I thought I would just start from the top, make my way down, offer some thoughts that I have, and give my recommendation based on what I think, although my recommendation I don't really think means much. But anyway, let's start with the top. So this top book is actually not a textbook. It's I don't know what you call it. It's more like a manual. How to Think About Analysis by Laura Alcock. And really all it is, it's kind of like one of those books recommended for undergraduates that are starting to get their hands dirty with proof-based mathematics, because math changes after a while. Like, you take calculus 1, 2, and 3, everything's good. You take ordinary differential equations, you take elementary linear algebra, and then you take math proofs. And you're like me, I struggled with math proofs. I actually ended up taking it, I took it twice, and then I was a TA for it one semester, and I think that semester, so that third time I saw it, actually, did I take it 4 times? I probably saw the material 4 times before I really started to understand how proofs work. And then after math proofs, it kind of becomes the cornerstone of everything you do in higher level mathematics. So you can see the table of contents here. This book is really good. It's very well written. I like this book. I believe I read it cover to cover a while back. But it gives you a way to think about real analysis from the proof perspective that, it may not make sense. What do I mean by that? So when I started taking higher level mathematics courses, and by that I mean like modern algebra, real variables, whatever it's called, modern algebra made more sense to me because, I'm not saying that every proof is like this, but my approach, the way I was thinking about modern algebra, the way I think about proving stuff works very well in modern algebra proofs, I think, because I didn't struggle. Like, if you give me a problem in modern algebra, like, I know where to start, and then I can play around with it and eventually learn where I need to go. It's just the way my brain works. But that's as opposed to, I'm not saying I'm a professional. I'm definitely not saying that. It's just that the way I think about proofs was better than it was in my way of thinking about real analysis. So that's what this book helped to do. So if you're a struggling undergraduate and in real variables, you're taking a real variables course, I think this book is pretty good. And that's what my real variables instructor recommended to me to buy, and I bought it and read it. It's a pretty, as far as textbook, it's not a textbook, but as far as books go, it's a pretty good read. So I recommend it. I don't think it was very expensive either, which is good. Okay, we are 4.5 minutes in, and I can't talk too much about every book this way, otherwise we're going to be here a while. So we'll go a bit faster. Intro to Real Analysis by Kolmogorov and Fomin, however it's pronounced. This book is built more for, I would say, that time in between taking undergraduate real analysis and graduate level real analysis. In fact, I used it when I used this book in my second semester of my second year in grad school. when I was getting my master's degree. This was, for a long time, my favorite book in analysis. I like the way he presents the material. It starts with set theory, goes to metric spaces. What else then? Topological spaces, linear space, all about spaces, linear functionals. So the first 6 chapters, I believe, is the best, like where this book really shines. And then past that, he gets into measure theory, because whenever you learn about measure theory, it's always from a real analysis course. I personally think that those 2 topics should be separated, but that's just me. What do I know? It's just that if I was teaching these courses, I would do like the traditional real analysis course, which you see at the undergrad level. And then for the grad level, I think I would call that more advanced version like functional analysis, where we cover the topics that you see, like in this book, like metric spaces, for example. Do a deep dive into metric spaces, and then go into topological spaces. Basically, the first 6 chapters of this book, plus a little bit more, would be what I would call a functional analysis course. And then everything measure theory gets its own course. So basically, I'm saying, take this one course and bust it up into 3 pieces. But, you know, I mean, what do I know? It's just what makes sense to me in the way I learn this stuff. But I like this book. The measure theory stuff, I don't exactly like the way he presents it. But the first 6 chapters are pretty good. Plus, Kolmogorov's a pretty famous probability theorist, so maybe he knows more than me. Okay. Again, a good book. Both of those books are good. Now, this book I haven't really read all the way through, and I was pretty eager to read it. Fundamentals of Real Analysis. My thesis advisor gave this to me. I think this book is relatively cheap, but I'm not sure. I got it for free because it was a gift to me. But he starts with measure theory. He talks about topology. So you can see here he kind of starts with measure theory and integral theory, and then he switches to function spaces, topics in measure and integration. So you can see here a lot of this is like measure theory based. And the reason, I guess I just lost interest in this book. I don't know, just this first chapter was just a drag. It just took forever to get through, and the way it's written, like inside here, let me get a good page. Like, it doesn't look too hateful looking at it, but just it was just that first chapter left a sour taste in my mouth. So I never really read the whole book, which is true. I never finished it. So I can't really say it's something that I recommend, but at the same time, I can't say that it's a bad book, because sometimes it's just a certain book will rub you the wrong way, and other times a book will just speak to you, like the way it's presented, just like, this makes so much sense the way the author is presenting it to me. I felt that way more about Kolmogorov's first 6 chapters than this book, so I prefer the Kolmogorov book for that reason. And this next book is the book that I used when I took undergraduate real variables. The name of the course changes based on, you know, the institution that's teaching it. But my advisor is the author of this book. When I got my my thesis. So he was my thesis advisor. And he stopped using this book after a while. I think I was the last group of students that he taught where he used his own textbook. And he talks about a lot of good stuff. So I'm very used to this book because it was like it was the first real variables book I had. So it imprinted on me. But he talks about a lot of really interesting things. It's kind of presented in the same way that most real variables textbooks are presented. I can't really complain about anything in this book. He does talk about Fourier series in here, which I think is interesting. I don't think that that's really a real variables concept. I think it's more of a grad school level concept, but maybe I'm wrong. And then he shoves all the logic and set theory stuff for like as an appendix. But it's a good, well-written book. I don't know how he feels about it, because I think he's critical of his own work. Like, I mean, we all are, really. No one's completely satisfied with it, but I don't think the book's... the book's accessible, you know. It's not too above your head, but it's also not underneath it, like it talks down to you or something. You can see here he finishes his proofs with a little smiley face, which I thought was a nice, wholesome touch. But this is definitely not a grad school level book. It's definitely for that bridge in between. Again, it's from calculus to analysis is what it's called. So it bridges the gap between your calc knowledge and a real variables course. So I recommend it. It's a good book. Now, unfortunately, if I were to recommend one textbook for undergraduate real analysis, it probably wouldn't be my advisor's book. It would probably be this one, the Bartle and Sherbert book. This book does not actually belong to me. I borrowed it when I was studying for my qualifying exams. But I really like this book. This book is presented in a very logical progression. What do I mean by that? Just the flow of it makes sense, like how they introduce things and the order that they present the material in is good. I mean, this book is famous for a reason. I like the problems in it. I love the pictures. I think it's easy to find information, which I always appreciate in a good textbook, especially if it's about mathematics. You can see just some of the problems. So I recommend this book, especially if I was teaching a course like this. This would be the one that I would use. I've actually daydreamed about that and like how I would set things up and you know, present the material. And I would definitely use that book, or at least the notes from it. All right. Now we get into the real stuff. So Measure and Integral, An Introduction to Real Analysis by Richard Whedon and Anthony Zygmunt. And you can see on the side here we have Chebyshev's inequality. This was the first book I had on measure theory, and it was the first book I had when I was in grad school and I took a course. Well, okay, I'm just saying the same thing twice. It was the book we used. We only used it for that first semester. That first semester was all measure theory, and the second semester was functional analysis. And you can just see the topics that they cover. Preliminaries, functions of bounded variation. We skipped this chapter. We skipped it. We did this one. Went straight to 3. We took our first test, was basically over chapter 3. And then we talked about Lebesgue measurable functions, the Lebesgue integral, repeated integration. I don't think we made it to chapter 7. I think that's where the semester ended. But then I went back and read through this book, and I read it from basically cover to cover. I may have skipped some, I know I skipped some things, but I eventually, you know, I was at least introduced to all the topics that was covered in this book. And this book covers things that you don't really see in a graduate level course. Would I recommend this to a beginning student that wants to get their hands dirty with measure theory? Probably not, because it's not a bad book. It's just it commits the sin like this, for example, like this page, for example. Like you read this paragraph and you're like, you see all the words that are in italics. Those are like definitions. To me, I think definitions need to stand out and pop at you so that it's easier to find information. Like, what if I want to look up n-dimensional cube? You know, if I'm starting out, then I have to hunt for it, and I don't like that. The notation that he uses is also a bit annoying in spots. Like, he denotes Lebesgue measure using the absolute value symbols. He gives, again, this is subjective because it's not what I like. So I can't really say, oh, don't buy this book because I don't like the notation. Maybe you like the notation, in which good for you. But it's just the way that he writes the material, and he leaves a lot of stuff to the reader to prove, which I thought was annoying. I would say that this is more for someone that's already seen some of measure theory and would like to take a deeper dive. Where's chapter 3? Is this chapter 3? Yes, it is. Vitali's theorem. There exist non-measurable sets. Yeah, anyway. Kerr-Theodori theorem. I don't know. It just rubbed me the wrong way. So if you're wanting to read more about measure theory, maybe pick it up. But I wouldn't really say it's the best. For me, I didn't like it when I first read it, but maybe I should read it again. I hate criticizing people's textbooks because I don't really think I'm in any position to criticize those books. So I guess this is my complex variables book. It's by Churchill, Brown, and Verhey. I'm not sure how to pronounce it. It's a thin book, as you can see. And it's kind of old and dirty. And I got what I paid for it, which was nothing. It was on a table, said free books. And I needed a book on complex variables. A beginner's book, because that's what this is. This is like undergraduate complex analysis. And I found it on that table, and I'm like, all right, I'm going to take it. And I read through it. I read pretty much, there was a couple of chapters I skipped, because the reason I picked it up was because I needed a book to study that was accessible for my qualifying exam in August, because I wasn't really learning much in class. I needed something to help bridge the gap, because what was in class was a bit much for me. But this book was really good. I like the way the book was written. Churchill and Brown really know how to present the material. So if you want a book in complex variables that's accessible to beginners, this one's probably what you want. It is a kind of a dirty book. So get one that's a bit cleaner than this. I got this one highly used. Differentiation formula. Pretty good book. Okay, almost done. Intro to Real Analysis, Brabenek. So this book is another undergraduate level real analysis book. And it's written pretty well. I kind of like the way it's written. It's kind of wordy in spots, but it has some good pictures, as you can see, to illustrate the idea. It has examples. It has nice proofs in it, too. I haven't read this book all the way through, but I've read the first couple of chapters, and it made me want to keep reading. It's just I didn't have time to sit down and read it when I wanted to. Prove that the limit as x tends toward negative infinity of x squared is equal to infinity. Yeah, so you can definitely see this is undergraduate level stuff. Definition of limits. Is it really this deep in the book where they talk about limits? Section 11, chapter 3. Yeah, so you can tell it kind of goes at a snail's pace. But I would recommend, probably Scherbert's a better choice. Bartle and Scherbert. Or is it Scherbert? I don't know. You know what I mean. Okay, 2 more left. We have the Stein book. Stein and Shakarchi. So this book does not belong to me. It is owned by a professor in real analysis and geometry at my university. I told him, I was thinking about doing research with him. We were just talking one day, and I told him about my qualifiers that I needed to pass, and I saw this book on his shelf, and I was saying that so-and-so really likes this book. And he's like, oh, you want to borrow it? I'm like, do you want to give it to me? He goes, yeah, I don't really read it much anymore. Like, he didn't give it to me. He's just like, here, you just read it and study it and give it back when you pass. So until I pass, it's mine. But you can see the stuff this book is good for like the like the person that I mentioned earlier that likes this book. So this book has like, it's a pretty famous book. What is this? It's Princeton Lectures in Analysis 3. There's different versions of this book. And the guy said that the first version is the best, and the second version it got worse, and then the third version, which I believe is this one, got even worse. Like in his opinion, they progressively got worse. I can't comment on that, but I mean, I think I see what he says based on the way the material is presented, because it's like the book's written very well. It's just I don't understand the logic and progression. Like the first chapter is measure theory, where he talks about Lebesgue measure. And then he goes on to integrals, which is fine. And then he talks about differentiation and its relationship to integrals, which is also fine. So obviously this is grad school level. And then he talks about Hilbert spaces, which is also fine. But it's not something that we talk about a whole lot in the graduate class that I had. So chapter 4, we kind of didn't really need to study. Chapter 5 is just more on Hilbert spaces, which we still didn't really need to study. And then chapter 6 is something that we covered first semester in my class. And it's a bit advanced for us at the time, but it still needs to happen. And then there's like some things from chapter 7, but most of chapter 7 you can skip. So Hausdorff measure, fractal dimensions, we don't really talk about at all. When I did my thesis, we studied fractal dimensions, so I kind of knew, some things about that when I read through this book, but we don't really talk about it much in the classroom. So like the first 3 chapters and then 6 is kind of the only thing where this book becomes useful. Again, this is at my school, and what I've learned has become useful. But if you're studying this stuff on your own, it's a very well-written book. I recommend it. It's just not my favorite, but it is pretty good. I mean, this one's famous for a reason. And the last one I got as a gift from my advisor, Real and Complex Analysis by Walter Rudin. Rudin is also another, we're going to see there, you can see his name up at the top. Very famous analyst. You can see just what he talks about in here. I have not read this book all the way through. I read chapter 1, I think. And chapter 1, he just presented the stuff in a way I just didn't like. I guess I'm just picky. I don't know. It's good though to read these books. Just because you don't like the way the the author presents the material doesn't mean that it's not useful to do. Because you need to see things different ways, because you learn better. You learn more by doing that, seeing things different ways. So my goal is to read through this book, because, Rudin's like a famous analyst. Like, everyone talks big about Rudin's books. It's just, when I read the first chapter, I'm like, people like this? I don't know what it was. I guess I just didn't like how he started. Like, where's the first chapter? Like, I don't really like the way how he just started with the Riemann, the Riemann integral, and just went straight to Lebesgue integral. To me, it feels like you need to spend a little bit of time talking about measure first, and then get into the integral. But again, I shouldn't judge this book because I haven't read it. But I'm sure it's a great book. So out of the whole stack, if I were to recommend one for undergrad, definitely the Bartle book, the skinny one right here. Hold on, let me flip this around without causing an avalanche. If I were to recommend a book for undergrad analysis, definitely the Bartle book here. It's probably the best one. I don't have too many books about complex analysis, but this Churchill-Brown book was really good. And then for measure theory, actually, my favorite real analysis book out of this whole stack is not in this stack. I have a PDF copy of Real Analysis by Royden and Fitzpatrick. It's available for free on the internet. And the way they write in that book, and the way they present the material and the notation that they use and just all the little details about it, I absolutely love. It's my favorite book on real analysis. So if I were to recommend one grad school level book, it would be the Royden book. Not Rudin, Royden. I mean, I'm sure, whatever, I'm not going to repeat myself. But it was my favorite. The way they presented measure theory and functional analysis in it was really good. So if you can afford a copy of it, I would recommend that one. The worst book in this stack? Oh, geez. I probably should just not say anything. They're not really none of them are really that bad. I guess the one that offended me the most was this one. The Fundamentals, the Berberin book. If I had to complain anywhere, it'd probably be that one. But just because that first chapter was just almost unbearable, like at the end, I just wanted to stop reading it. But anyway, those are my thoughts. Let me know if there's any good analysis books out there that you recommend I read, because I'm always interested in reading more. And again, thanks for watching.